Glad to be here. Again, I'm a geotechnical engineer. Not very many of you are geotechnicals here. Yesterday we took a count, maybe 5 of us attending this conference. But let me tell you that this has been a very, very exciting and experience for me. A lot of research going on in the hydraulics. What I felt in last 3 days is for sure hydraulics is much more complex than geotechnical. And so what I'm going to talk about today is like real simple things, not going into like research, may trigger a research or two after this presentation, but very simple things, some research that is ongoing in the coastal environment and stuff like that. So today I'm going to be talking about integrating nature-based resilience for Levee wave wash protection. So nature-based solution, it features or mimics characteristics of natural features and processes, but are created by human design and engineering. These features can protect coastal infrastructure from burnt-off storm surges and waves. They can also provide other benefits such as recreational opportunities, habitat needed for commercial fisheries, healthier environment, and so on. This is a typical cross-section of a living shoreline section. Whenever we think of a stream bank stabilization or shoreline section, what we generally think of is a traditional solutions, riprap or big blocks, concrete blocks. But this is a new approach, and there is some research going on and using this living shoreline or some of these nature-based principles to design these. Why is that? This is something I came across yesterday, and if you see this when you have the vegetation inside this channel or the coastal areas, what happens is this wave, when you have this energy profile, when you have no vegetation, the wave energy profile is like this. The moment you have some vegetation, the wave energy drops down wherever you start the vegetation and then drops by the time you get to this one. There is a lab in Netherlands is doing some study, and this is internet does not work here. So there was a video on the internet showing that, and that the website name is Wood versus Waves. Okay, and what they are doing, they are testing this resilience of vegetation against the wave. Matter of fact, they have done the flume test, and that video is available, but they're looking for a crowdfunding, and they're going to be testing this huge flume, which is like a 4.5, 5 meter wide, and the wave height could range between 4 to 5 meters. So it's a very interesting. Sooner they are going to be testing that, and sure enough, there will be some outcomes in these lines. So why use natural features instead of conventionally engineered protections? The conventional protection includes walls, seawalls, bulkheads, revetments, and unfortunately, the function of shoreline has been significantly altered because of the interaction of conventional protection strategy with natural processes. The results include reductions in sediment transport and the loss of wetlands habitats and beaches, among the others. Now, this nature-based solution is something started in the Europe a few years ago. It started by European commissions, and they are implementing these studies and using these in stream bank stabilization work, coastal works, and roadside erosion mitigation applications. What about the cost now? Nature-based solutions can be less expensive than others, especially where the wave action is less in the coastal environment. And again, this whole thing, it's not my research. This is something ongoing research, FHWA's research. Initially, I was going to use some data from the European studies, but then I came across this site yesterday. Scott Douglas brought up this research, ongoing research by the FHWA, and they have published some data. And that's where I have taken some of these findings and presenting it today instead. So stream bank and shoreline protection using nature-based solution. This is something coming from, again, the shoreline stabilization manual. Earlier, these used to be known like a soil bioengineering techniques. Now it's more so, it's a nature-based. There are different goals and different type of research going on. So this is nothing but just a joint planting or a vegetated riprap. Again, so you have that vegetation, and what that does is reduces the stresses coming onto the bank or the energy dissipated on the bank itself. Other solutions available in the marketplace, again, the alternative to traditional or conventional riprap, wire enclosed riprap or wire enclosed mattresses. Now, again, designed using HEC 15 manual. Design procedure is outlined, very detailed in the HEC 15 itself. These solutions, when it comes to nature-based solutions, what we have altered lately is we are changing these solutions. Instead of doing just filling that with rock and then leaving it to the nature to sediment and vegetate, we're taking a proactive action wherein we are proposing it to be filled with stones and the topsoil with some seed mix, and then top it up with a turf reinforcement mat that will create a structure that can protect the root mass of this vegetation under the shear stresses or the velocities. Another in the stream bank stabilization, when you have a geotechnical concern, riprap may not work because that bank is not stable. If the bank is stable, if your slopes are gentle in terms of like 2 to 1, 1.5 to 1, 3 to 1, those slopes are stable. The moment you go beyond 1 to 1, those slopes are not stable. So there is a need to stabilize that slope using different techniques such as reinforced soil slope or the retaining walls or some sort. And these reinforced soil slope, they are typically laid down at 60 degree minus, 70 degree minus, so they are termed as a slope, but 60 degree and less is where you have the vegetation success or the vegetation, a lot of vegetation growth. And these reinforced soil slopes can be designed with the vegetation component inside itself and can give you a natural looking bank instead of having a bank which is a rock riprap or any other conventional methods. So in this project here in Indiana, Evansville, Indiana, the Levee system was damaged along the Ohio River and Pigeon Creek during the spring of 2011 flood event, and the levee incurred approximately 3,000 feet of wave wash, erosion along the most of the riverfront of this NHEC or township. So here you can see this wave wash and the failure here. At the toe they had a gabion and then the rock riprap, but on top of that it was again just the vegetation by itself. During the 2011, again during the floods, the water level rises, and then they have this toe failure on top of this existing gabions. So this was not the first time it was flooded in this area. Even a few years before it was flooded, the same section, and they did some repair. So this time around, Morley and Associates were engaged to design this the solution for this ongoing issue. So here in this sketch, you can see this was the wave wash area, and that in the picture you can see it here. And again, the vegetation from this section was all gone, and you see this some trash or the dead vegetation in this area. So the initial proposal was to design this with this riprap, about 18 to 24 inch riprap here in the wave area, or the maximum water level in this area, and on the top, again, smaller thickness, maybe 12-inch thick riprap, in order to accommodate any future events which will exceed this high water level. But then again, CT and the Army Corps of Engineers were looking for something which will, again, reestablish the green surface on top surface here, at the same time have some resilience for future event. So Morley and Associates designed this one with, again, the bottom section with the riprap about 18 to 24 inch, depending upon one location to the other. And then on top of that, a turf reinforcement mat reinforced with a wire mesh was used in order to increase the resilience. So the MacMat R, which is like a three-dimensional synthetic matrix here, which is extruded over hexagonal double-twisted wire mesh. And 3 months later, you can see all the vegetation established. What they did is the toe gabion, this is the existing toe gabion. They increased the toe gabion height, or the toe protection height, by adding another small gabion on top of that, and resurfaced this, lined with a MacMat, and let it vegetate. So the resilience is built through the vegetation root reinforcement. Earlier also there was a vegetation, but the vegetation root reinforcement was missing, and you see during the wave action, all the vegetation was gone. In this case, you have, in this picture, you can see here that all these root mass going through this three-dimensional matrix, and in this picture, you can hardly see a product there. Little detour here, the burrowing animals and embankment stability. Has anybody seen this situation during the inspection? Not very often. Look, these are the rodents, right? Or the beavers, this is the population or the existence in the North America. They can be seen anywhere in the United States. Okay, these beavers, they could be anywhere between 40 to 50 pounds. These are big animals who chew through the trees within a day. Okay, so if they start in the afternoon, by evening you have the tree which is fallen. Right? And not only that, but they are burrowing into the levees and the stream bank. Right? Now, if we see this, now this is from Ohio DNR. The statement there is beavers living along a river make burrows with an underwater entrance into the river bank. The population, if you see it, in Ohio alone, how many rodents do we have here? This is a count during 2008, 2009, about 45,000 rodents. Then the similar concern in the Levee Owner's Manual from Army Corps of Engineers, where they're talking about similar issues. May not be readily available, detected without thorough inspection. so on and so forth. Again, another issues where additional concerns in the streams and the channel improvement projects caused from building the dams, blocking the culverts, creating the stream bank instabilities, and so on and so forth. Here you can see it again coming from the Army Corps of Engineers manual. Similar concern throughout the country. Here you can see it in the Santa Carla Valley in California. We are working with the NRCS office there on some of these projects. California Levee and Vegetation Research, what the research concludes is the burrowing mammals are considered threat to the levee integrity, and their burrowing activities have been implicated as cause of numerous failures. Again, a dam safety manual or the pocket guide for dam safety guide for the dams and impoundments, similar concerns there. So the damage reduction methods for the rodent in general involves lethal approaches, okay? To reduce the density, what they want you to use is pesticide that kills the rodents, or baiting, or introducing predators. That brings another problem. Or trapping them, or fumigating them, shooting them, or even better, exploding the whole levee. So here there is some findings from Alabama DNR. What they are saying is nothing seems to be working here. So habitat modification does not work. Exclusions does not work. Frightening, they don't get frightened. Toxicant, no. Fumigants, none are registered. Shooting, okay. Nice, right? Nice training. I mean, we don't need a. So and that's not the only rodents. You have many more. So you have muskers, you have badgers, ground squirrels, prairie dogs, gophers, and many more. So what we have done is we have used this MacMat-R and wire mesh products and done some on-site research or field studies in Germany and Europe, wherein we have taken this, and I have published this research last year in Dam Safety Manual, our Dam Safety Conference last year, and just to see what happens when you use this type of protective measures to prevent these levees or burrows in the levees due to this burrowing animals. With that, in the conclusions, effective root penetration and the reinforcement permanently safeguards the bank against wave wash. Steel mesh reinforcement prevents the shallow slope failure, not only encourages the vegetation growth, but also avoids any shallow failures or the sloughing type of failures. Prevent instability due to animal burrow, and it's like a triple win solution where there is a win for nature, win for economics, and win for well-being. With that, I will take any questions. Thank you.